Today we're going over vectors in a plane. So what is a vector? A vector, just an example drawing down here, is generally where we've got a movement from one point to another. Let's say P is our initial point, Q is our terminal point, and it is written in bold letters, right, with a kind of looking like this, where you got P is our start point, Q, and it's kind of like the ray symbol. It's an arrow going to the right over top, but it's only a half arrow, right? So vectors have magnitude and direction. Magnitude means length, whereas direction is kind of which way we're going. And when are vectors used? They're used quite often in physics, right? We were talking about forces and velocity. And when are vectors equivalent? When they have the same magnitude and direction. So in this lesson, we're going to go over how to add vectors, a little bit of scale and multiplying of vectors, and things like that. Component form of a vector with initial point P1, PQ, and endpoint, terminal point Q1, Q2 is given by, and there's that symbol again, vector PQ is, notice, Q1 minus P1, right? Terminal minus initial. And then same thing, Q2 minus P2. They consider this the horizontal component and a vertical component, just like X, Y. Also, they use these brackets to put them in, because they're not points, but it's a direction. Magnitude, let's say this is vector V is V1, V2 here. So magnitude of V, using this double absolute value symbol, is V1 squared plus V2 squared all under a square root, right? And that's what that is. If the vector's magnitude is 1, it's a unit vector going 1. Moreover, if the vector's magnitude is 0, if and only if it is a 0 vector. Find the component form and magnitude of the vectors. Now we started at -7, moved to -1, 5. And so we've got to use our Q value, -1 minus 4 over, starting at the Q value, 5 minus -7. So -1 minus 4 is -5, 5 double negative plus 7 is 12, and there's my unit vector, sorry, not unit vector, there's my component form of the vector, and then finding the magnitude, just plugging in, -5 squared plus 12 squared is going to give us a 13, because it's a Pythagorean triple. I'm going to show the math here. 25 plus 144 is 169. Square root of 169 is 13. And again, they consider this the magnitude of vector PQ. One more time without the picture. Again, we're starting with 2 and 6 here. So we've got 2 minus -5, 6 minus the 7. So we get -1 over there. Double negative is positive. They get 7 over here. So there's my whatever PQ, vector B, there's my component form. Make it look a little nicer here. And then just squaring each one. So usually I just do it this way, where I'm squaring as I go down. And then square root of 50, which is 25 times 2. And square root of 25 is 5. So this is 5 root 2 is my magnitude. Next, some more rules with vector. So addition is simply you add the components that are horizontal, and then you add the components that are vertical. Just adding them up, whether they're positive or negative. Scalar multiplication is basically k times both numbers, right? So if we did k times u, it would be the same as k times the horizontal component, and then k times the vertical component. We're not adding there, so it's just multiplying. So say this is our vector v. Half v would be the same direction, but half the length. If we did 2v, we'd be double the length, right? Again, same direction. Negative v switches which direction we're going. Now we're going down to the left instead of up to the right. And negative 3/2 v is a combination, right? We're going down, but we're also going 3/2 more, right? 3/2 times. So just a little note, if we're adding vectors, let's say we had just 0, 5 for u, and let's say 3, 1 for v, right? So 1, 2, 3, 4, 5. So we'll just happen to start here. It doesn't have to be the order. So that'd be 0, 5, and then 3, 1. And v. So u plus v is the same as v plus u. Right, so order doesn't really matter there. And our resulting vector would be a complete diagonal across. Kind of make it a little bit. So starting off, sketch the graph of u plus v, given u is 5, 2, v is 0, negative 4. So you can do this, just line them up. I'm going to add 5 plus 0, 5, 2 minus 4, negative 2. So my answer is going to be 5, negative 2. And there's the results. Drawing a picture would look something like this. There's my u, here's my v, and that's why I ended at that. 2u minus v becomes 10, 4, and then minus v, 0, negative 4. So I'm just going to do negative 1 distributing to get us 0 plus 4, and then adding those together, we get 10, 8. So 2, 4, 6, 8, 10 over here, 2, 4, 6, 8. So up there, this is my answer vector. We put it together, we're then 2, 4, 5, 2, 2, 4, 5, 2. And you can also draw it this way, u, and then this is the minus v, right, just to see where that came from. Next, properties of vector addition and serial multiplication. Adding, order doesn't matter. If we add parentheses, we can still work. So they're like associative, commutative, right? If we add 0, it doesn't change. The opposite of itself is going to add equal. The 0 vector, c times du equals cd times u. Again, notice c and d are scalars, so it'd be like 3 and 4, right? Just numbers. We had 3 plus 4 times u. We can distribute going this way, cu plus du. We can also distribute if we had 2 vectors adding together, c times u plus c times v. 1 times anything is itself, 0 times anything is 0. And if we had something like 5 times v, and we wanted to find the magnitude, you can just find the magnitude of v and take that 5 out. Now, absolute value of 5, of positive 5 is 5. So if it was also negative, this would also be 5, because distance is always positive, right? Magnitude is always positive. Direction and angle, right? So direction comes from tangent. Tangent is sine over cosine or y over x. So when we have something like this, vectors x, y, our angle, right? Tangent of our angle is y over x. So tan inverse of y over x is our angle. Okay. These are a couple more ways that we can rewrite the same vector. So notice if you see i's and j's, that's just telling you that that is the same as vector x, y, right? I is just telling you horizontal component, j is just telling you vertical component. We can also write it as magnitude of v times cosine of the angle plus magnitude of your vector times cosine of the angle times j. So that means cosine is going to be our x value, sine is our y value, so you can rewrite these, just take these pieces out and put them over here. Okay, magnitude of v cosine of theta for the x side, magnitude of v sine of theta for the y component. Line u plus v, 3u minus 4v in the direction. Okay, so u plus v we have set up. 3 minus 3, negative 2 plus negative 2, and negative 0 minus 4 is u plus v. Okay. 3u minus 4v is 3 times 3, negative 2, minus 4 times negative 3, negative 2. We get 12, 8 over here. And I did a minus 4 multiplied. We'll roll backwards here. 3 times 3 is 9. 3 times negative 2 is negative 6. And now I'm adding 9 plus 12, 21. Negative 6 plus 8, 2. So I have 21, 2 is 3u minus 4b. Lastly, direction of angle b, we're taking this and giving tan inverse of y over x. So that's tan inverse, negative 2 over negative 3. We'll get an angle. Now this angle is a reference angle. Okay? So tan inverse. So my calculator a little small here. Second, tan inverse of negative 2 over negative 3. So they're both negative. You got to use the bottom negative sign on one more. You get 33.69. Not the right answer, but I'll show you how it's going to help us. So this is 33.690, rounding to 3 decimals. They were giving us this value here, right? Where is vector negative 3, negative 2? So negative 3 this way, negative 2 down here. So because tangent has a period of 180, we need to add 180 for degrees to that. And this will give a final answer of 213.69 degrees is our direction. You can test it out by doing the magnitude cosine of that, right, and the magnitude sine of that to get back to our original. But we'll save that for a later slide. One more time, u plus v, we've got 3, 7, negative 2, 3. We're just going to add them together. So I get 110 is u plus v. 3u is going to be 3 times 3, 7. Going to be 921 on brackets at all. And then minus 4 times v, which v is negative 2, 3. Be negative 8. No, I'm sorry, double negative. So plus 8 minus 12, and now adding those together, it's 17, 9. It's 3u minus 4v. Now I got direction here. This is the same as negative 2, 3. Similar. So we're doing tan inverse of 3 over negative 2. And this will get us negative 56.310. And again, not quite the answer we want, because this is negative 2, 1, 2, 3, and the answer they gave us is down here. So again, we need to add 180 to that. We're going to get 123.69 degrees is our angle. Okay. So again, this is this, and if you think about it as a point for a second, just draw that, and that will tell you whether tan inverse, right, giving us quadrant 4 and 1 will make sense. Next, unit vectors. Okay, unit vector is a vector that goes 1 unit. So what you're going to do is take your vector, which let's say it's got a magnitude of 5, and then we're going to divide it by 5 to find 1 unit length. So same idea here. So here's our formula: vector divided by the magnitude. All right, so we need to square both of these. And then we're going to get 9 plus 49 is 58. So now I'm multiplying, or dividing, both these pieces by square root of 58, and then we're going to rationalize. Leave some more space. So rationalize is this. Making sure my denominator doesn't have a square root. The final answer to do that is 3 root 58 over 58, 7 root 58 over 58. Next, we've got negative 2 squared plus 3 squared. 4 plus 9 is 13. And then it's again negative 2 over root 13, 3 over root 13. And when we bring that root 13 up, looks like this. And there's our unit vector of negative 2, 3. Last part, find the component form, given its magnitude and the angle it makes. I'll draw this out so it can make a little more sense, but we have 120 degree angle And we're looking for what these values are here. What's our y, what's our x percent, right? And so we know the length is 4, right? And now we have this angle here that's 60 degrees. We can use our unit circle, right? As a reminder that this is 2x, so I can solve quick. X is 2, and then solving for this height is going to give me x root 3. Well, x is 2, so I get 2 root 3. Now, x is in the negative direction here, so my answer is going to be negative 2 root 3. Now, another way to figure this out besides drawing is using that magnitude cosine of angle, magnitude sine of angle. And so that's the recommended way. We've got 4 cosine of 120, 4 sine of 120. And again, 120 degrees, generally on our unit circle, is a point negative half, positive root 3 over 2. So just pulling that in, 4 times negative half, give us negative 4 halves and negative 2. And 4 times root 3 over 2 gives us 2 root 3. Okay. And that wraps up today's lesson. Feel free to ask any questions.